All right, so today we're talking about choosing the strategy that you use to solve a system. So basically, it's a matter of collecting data and then saying, based on the data that I've collected, how do I want to approach the problem as efficiently as possible? All right, so 6-1-12. Erica works in a soda bottling factory. As bottles pass her on a conveyor belt, she puts caps on them. Unfortunately, Erica sometimes breaks a bottle before she can cap it. She gets paid 4 cents for each bottle she successfully caps, but her boss deducts 2 cents from her pay for each bottle she breaks. Erica's having a bad morning. 15 bottles have come her way, but she's been breaking some and has only earned 6 cents so far today. How many bottles has she capped and how many has she broken? So I can hear by reading that there are capped bottles and there's broken bottles. So I've defined my variables that way. And I also hear that there's equation that has to do with money, and there's also going to be an equation that has to do with the number of bottles. And so I'm going to start with the fact that there are 15 bottles. So the capped bottles plus the broken bottles has to add up to 15. I can also hear that there's the money one. And so it is 4 cents, and they've defined this with the cents symbol. So I'm going to go 4 cents per capped minus 2 cents per broken equals, and she has only made how much? 6 cents so far today. All right, well, that's a bummer. And so I'm looking at this and I'm saying, I don't have two equations that both start with C equals or B equals. I don't have one equation that starts with C equals or B equals. So I could either rewrite the first equation and substitute it into the second equation. I tend to go with elimination at all costs because I feel like it's the most efficient. I would probably multiply the first one by 2 on both sides. And so I would get 2C plus 2B equals 30. And then I would have the 4C minus 2B equals 6. And I looked at this and said, oh, look, they already had opposite signs on the B's. So 2C and 4C make 6C equals 36. Divide both sides by 6, C equals 6. So she's capped 6. And then I would go back to like my first equation and say, C plus B equals 15. So 6 plus B equals 15. If I take away the 6, I would get B equals 9. Now, if you wanted to go the substitution route, which also is going to be effective, you could solve the first one, right? The first one was C plus B equals 15. If you let's say you took away B from both sides and got C equals negative B plus 15, you could substitute that into 4 times C minus 2B equals 6. And then you could distribute. And I mean, this is going to work. It's going to depend on which way you personally feel more confident. And I still get the B equals 9, right? And so the broken bottles were 9. And then if I want to go back, I can say C plus 9 has to equal 15. Take away 9 from both sides. C equals 6. So, I mean, I really did get, the same solution, just 2 different ways of doing it. So you could do elimination. You could do substitution. I would not, in this case, suggest equal values because the second equation is going to be really messy to solve for a single variable. 6-113. For each system below, decide which algebraic solving strategy to use. That is, which method would be most efficient, or setting the equations equal to each other with, substitution, elimination, or equal values. I started to read the middle of a sentence, sorry. But we're not going to solve anything yet. All we're going to do here is just sort of pick. Because this one already is set x equals, but the other one is not. This one's probably going to be substitution as your best bet. The one across from it, B, you'll notice that the y's, right, have the same coefficient, and I could just subtract them. So I would go with elimination. C, both of them start with x equals, so that one's probably going to be the equal values method. D, well, this one has an equals x, so this one I could do substitution. It would take 1 step extra if I wanted to do the elimination method, so you could go either way on that one. Substitution is the one it's set up for. E, that one starts with a D equals. I would probably go with substitution again on this one because I can just substitute all this stuff on the right in place of the D. F, well, F looks like I'm set up for elimination as long as I do one step, right? So I might need to do like the second equation times 2, and then I would have a negative 6x with a positive 6x. So I'd probably go with elimination. G, I already have one positive, one negative here on the plus 3y minus 9y. So I might multiply the first equation by 3 and go with elimination. And H, I've got this equals y, but not on the second one, so I'd probably go with substitution. Equal values method, you'll notice, does not come up nearly as often as the other two. So 6-114 says solve one of these systems using substitution, one using elimination, and one using equal values. What I will do is provide you with the solutions to one, negative 1/2, 1/2. Substitution on E, since it's not set for X and Y, we would say D equals 20 and W equals 3. And then G right below it, 0, negative 2. Up here at the top for B, elimination is 1, negative 2. And then for H, substitution, it is 10, 7. What I do want to do are D and F. And that's because D and F are the sort of unique ones that tend to cause problems that people think they've done something wrong. So D, we said we were going to go with substitution. So the first equation, 2x minus 4y equals 10, I'm going to do 2. The 2y plus 6 is going to get substituted in place of the x. Minus 4y equals 10. So I'm going to have 4y plus 12 minus 4y equals 10. So the 4y minus 4y, we get 12 equals 10, which is not equal. And anytime we get a solution that has all the variables gone and two numbers that are not equal to each other, that system has no solution. So that's the one that people tend to say, oh, I must have done something wrong. Nope, you didn't. The other one was F, and I have negative 6x plus 2y equals 76. If I multiply the second equation, 6x minus 2y equals, and the negative 38 times 2 would be negative 76. So when we go to, add or subtract, when we go to combine those two for elimination, I'm going to get canceled, 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 and I'm going to get 0 equals 0, which is a true statement all the time. So because 0 equals 0 is a true statement all the time, no matter what values of x and y we pick, we would say this has infinite solutions. So the answer to D was no solution, and the answer to F was infinite solutions. And happy in class to do any of the other 6 if you want me to. But the answers are provided there. The solution to the systems are provided just in case you want to practice on any of them. All right. Bye.